All right, so today what we're going to cover is learning unit 4, which is regression and correlation analysis. All right, so I'll take you through what it's all about and just shout if there's anything you're not sure about, if you can't hear me, or if there's any technical issues. All right, so let's ignore all of this. Let me just create a new whiteboard, right? So the one thing you would need to understand is the equation of a straight line, and because that's what we're going to be using. So regression is all about making estimates. So, okay, so I'm going to draw what we normally call an X and a Y axis. So this is your X. Just give me 1 minute. Sorry, my little one just interrupted me. All right, so now coming back to our drawing. This is your x-axis and this is your y-axis. Now the y and x could represent anything in real life. For instance, x could represent, let's say, how much experience you have in months, right? And your y could be your salary. So as you would expect, the more experience you have, you can expect your salary to be higher. So in other words, the relationship would be, if I had to like plot some points with these x's, it'll be somewhere like this. As you start moving to the right for x, that you'll find that your salary is increasing. Now, what we would like to do is to be able to make an estimate. So say someone new comes along, and I'm going to mark this person with an X. This person has this month experience, so somewhere around here. Now you can see there's no X or data point that corresponds to this X value. You can see there's nothing there. All right, so what we want to do is we want to make an estimate of this person. We don't know exactly what it is, but we can just make an estimate. And how we make that estimate is by using the blue points, the points that we know. We use the blue points to create a straight line, and then we're going to use that straight line to estimate what this red value should be. So the whole idea is we use the blue points and we fit a straight line like this to the data points. And we could draw many different straight lines, but I'll show you how to get the optimal or the best line. That's what this section is going to cover. So what we do is we fit this green line, and we use this line to make estimates. Now, how we use this line, and this is going back to maths in high school, for any line, right? So let's say you got two lines. I'll maybe just draw another set of axes here. So I have a line in this color. Let's say this purple color like this. Oops. This line would look like this. And then I got another line that would look like this. Now, what makes these lines different is two characteristics. These two characteristics is where they cut the y-axis here and how steep the slope is, or the gradient. And we write the equation of a straight line like this. So this is back. So we write it like this. Y, I'm making up a number here. So let's say this equation for this purple line is y equals to 1x or 1.5x, give it a decimal, 1.5x plus 3. And then the other line, the red line, would have an equation like this. Y equals, and you can see that this line is steeper. Okay, it has a steeper slope. So the value in front of x would be greater than 2.5. We'll make up a value, 2.1x plus 2. Now this value in front of the x tells you how steep the slope is. So this is your gradient. Okay, this is your slope. And this line, this red line, because it's steeper, you would expect the slope to be more than 1.5 than the purple line. Now, essentially what I'm trying to say is if you have these two values, the slope and you have the intercept, and you have everything you need to describe that line. And how you use these two values is, if I want to make a prediction, right, the best I can do is use the value on this line, right? So say this equation for this green line is y equals 1.2x plus 1. If that was the equation, then if I wanted to guess what this predicted y value is, if I wanted to guess what this value is, all I need to do is feed in this x value. So say this x value is 2. All I need to do is feed in this 2 into this x, and I'll get y equals 1.2 times x, but x now is 2 plus 1. And this value here, which is what, 2.4, 2.5, I think. But you get the idea. This 2.5 is what's going to be the estimate for this data point here. So in the real world, if this x was, suppose how much experience you have in months, so this was your experience, let's say in years, okay? And this was your salary, your y was your salary. Then what we're trying to guess is, what can we expect to pay someone who has 2 years of experience? And that value there is 2.5. And it could, this measurement could be in, hundreds of thousands, etc. So it'll be 2.5 times 100,000, or it could be a million, etc. Right? Depends on the unit. Okay, does that make sense? So this is how we're going to use the equation of a straight line to make estimates. I'll explain how we get the lines, but the important thing is to understand what a straight line equation is and how we would use it. Okay, let me just stop there for a second, check if there's any questions. If there's not, I'm just going to continue, but please feel free to interrupt me and ask away. All right, so now let's look at a problem that you can expect to have in your exam and your second assignment. So in practice, you will be given, let's just say 2 columns. You will be just given these columns here. You don't really need to know the names of these people. So what this table is telling you is the first person has 52 months of experience and their salary is 381,000 Rand because the salary is measured in thousands. The next person, Sarah, has 63 months of experience and she gets 442,000 Rand, etc. All the way to the bottom, the last person, which is Ethan. He has 77 months of experience and he has a salary of 610,000 Rand. So the graph that you see here on the right, that's all those data points that I'm mapping here. So the first person is Jill, which is this point here. This point here is Jill. The next point is Sarah, yeah, etc., etc. So I basically mapped all the points, okay? Your months of experience on your x-axis and your salary as your y. All right, and then you've got these points. Now, what is important for you to determine is what is your x and your y. Now, you won't be told that necessarily in your exam. You need to figure out which is the x and the y. And how you do that is you look at what variable is influenced by the other. So for instance, I can tell that the more months of experience you have, that is likely to affect your salary, okay? But it's not the other way around. It's not that your salary affects your experience. So whichever one is being influenced by the other variable, that is your y variable. So in other words, your salary is being influenced by your experience. So that means x is the experience and y is your annual salary. And we have specific names for this x column. It's known as your independent variable because it doesn't depend on anything. And then the y variable is your dependent variable. All right. Okay. So just remember that if you're asked to determine which is the dependent and the independent variable. Now, it's very important to understand which is your y and x, because if you mix that up at the beginning, then everything is going to go wrong. So make sure you understand how to identify which is x and which is y. All right. Now, what we need to do is we need to find the equation of a straight line that would best fit this data so we can use it to make estimates. Okay. So if I draw a line here, like that, I will say that this is the best line, but we want to know what is the equation of that line. And we're fortunate that we have formulas to determine that for us. Now, remember what I told you about a straight line? You only need two things to describe it. You need to know the slope. Okay, we'll call it B. And then we need to know the intercept. And that'll be your A. So in other words, we need to know A and B, so we can write the equation as, let me change the color. The equation will be y equals to A plus bx. Okay. All right. Now that's what we're going to determine using our calculator. All right. So remember, we are only given these two columns. All right. So what I want you to do is get your calculator out, and we're going to use the regression function today. All right. So with your calculator, after you switched it on, I want you to press shift. Sorry, I want you to press a second. Yeah, press mode, and then choose stat. And then you will see one of the options, which should be option number 2, which is A plus bx. All right, that's the option I want you to select. All right, so just do that for me. And then when you do that, you should be presented with 3 columns, an x, a y, and then a frequency column. All right. Okay, once you do that, then what you're going to do is you're going to capture the x values here and your y values here. So for your x values, you're going to capture everything from 52 all the way to 77. And then for the y values, you're going to capture everything from 381 all the way to 610. Okay, so just once you've done it, you can ignore the frequency column. You don't have to worry about entering anything there. Every time you enter something, it should just get populated with 1. So you can ignore this. It's just these 2 columns you got to capture the data. Okay, so once you've done that, just raise your hands in the chat so I know you've done. Okay, so please capture those values. I'll check the chat for a second. Okay, I'm assuming you're still capturing, but please, yeah, raise your hand once you've completed it, so I know. Both. Fantastic. Thanks, everyone. Okay, you can lower your hands now. Thanks, everyone. All right, so now you've captured the data. So what you can do is you can press AC. Now the shortcut to get A and B, it's actually very simple on your calculator. Okay, so this is the shortcut to it. All right, so all you're going to do is, once you press AC, just press Shift, then press 1, and then you should see an option that says REG. Okay, so Shift, then 1, and you'll see an option that says REG. That's regression. Choose that option. And once you select that, you'll see your A and B is there. So if you want your A, select that one, if it's option 1, and it equals 2, right? And you should get a value for A of minus 115.89. All right, now do the same thing for B and write what you get in the chat. Follow the same process. You tell me what value you get for B and write it in the chat. Remember, shift 1, REG, and select B. Okay, if anyone's stuck, let me know, but you should get an answer of 9.24. Oops, 9.24. Round it up. So your equation of the line is, if I to write it out, is this. Y equals minus 115, because all I'm doing is I'm replacing A with what I found here. Right, minus 115.89 plus 9.24 x. That's your equation of the line. Okay, now the way I've showed you how to do it is the shortcut. Okay, that's the shortcut to get A and B. Just keep in mind, though, that more often than not in your exam, you're expected to do it the long way. Okay, you're expected to use these formulas to do it. And I'll show you how to do it. It's actually very simple. Okay, so the first value we're going to get is B. We're going to do B first because, as you see, you need B to determine what your A is. Okay, now, if I want B, I need to find all the values in this formula, and your calculator will do all of that work for you. All right, if you want to know all those values, remember, if you look at this formula, you need N, you need sum XY, you need sum X, you need sum Y, etc. You need all of these values. If I show you how to do one of them, it's actually very easy to just figure out all of them. All right, so let's just work out sum XY. Right, this value here. To get this, it's very easy. All you gotta do is press AC to start on clear screen. You're gonna press Shift. You're gonna press 1, and then you're gonna select the option that says Sum, because this is what it is. It's a summation. Choose Sum, and then you'll see this option here. All right, and whatever number that is in my calculator, it's option 5. So you just select that. It equals to, and you'll get a value of 243,305. Okay, you can do the same thing to get sum X, sum Y, etc. All right, and sum Y squared as well, sum X squared. All right, so you need all of these sums to put it into input into this formula. So once you've found all those sums, all you need to do is write out the equation with those values. Okay, so clear this out. So what you would have in that formula is simply, remember N, you can also find N as well. N is just the number of rows of data you have. If you count how many data points you have 1, 2, 3, 4, 5, 6, 7 data points. All right, so that's your N. So you'd have 7 into, all I'm doing is I'm writing all the values into this formula here. 7 into 243,305 minus sum X, which is 472 times sum Y, which is 3,550, all over N, which is 7, sum x squared, which is 32,252, minus sum of x all squared, which is 472 all squared. Right, and if you work this out in your calculator, now I don't recommend you actually try and punch all these values into your calculator. You've done all the work to show that you've done it the long way. All you need to do is just say equals to and use the shortcut to work out b, like what you did earlier, 9.24. This must equal to 9.24. You can enter it as you see here. You can enter this in your calculator. It's up to you. But whichever way you do it, you must get this answer here, 9.24. Okay. And then you do the same thing for A. Okay, you get the values for the sums. You now have B, so you can input that 9.24 for B, and then you'll work out A. All right, so if you do it the long way for A, the value you should get is the same as what you did using the shortcut, which is minus 115.89. Okay, I'm just going to pause it for a second. Nice, Jenna. Very good. All good? Okay, just let me know if there's any questions. Okay, now we've got this equation. Now let's use it. Let's use it to make estimates, because that's what the whole idea of this section is about. It was to use that straight line to make estimates. Okay, now we've got this equation. I'm just going to clean up the board a bit.
Hi, Dara.
Yes, Thomas?
Yeah, I just want to check. You see where this box that you just highlighted, the y equals to 115 dot. Is that the slope of the line?
No, the slope is whatever's in front of the x. So
Okay.
it's a 9.24. See, there's your x. Yeah. So whatever's in front of it, that's your slope.
All right.
Which is 9.24. That would be your b.
Okay, sure.
Okay, good question. All right, so got the equation. Let me just write it a bit neater. Okay, so that's our equation. This is really messing this up here. Let me write it neater. Plus 9.24. All right, so now we've got this equation, and we're going to use it to make estimates. Now, if you look at all the data points here, we have people with different months of experience, but let's say someone comes along who has 65 months of experience. So for instance, someone has 65 months of experience, your X is 65. The question is, what is an expected or estimated salary for someone with 65 months of experience? Someone with 65 months of experience. That's the question. All right. And so all we do is we use this equation, and where we see X here, we substitute 65. So you put 65 in this equation. And so you'll have minus 115.89 plus 9.24 times 65. And if you work that out, okay, if you plug the 65 in, the value you'll get for y is 484.703. So your estimated y when you put the 65 in, you'll get is y equals 484.703. Now, general convention is instead of writing y, because what we're doing is we're making an estimate, right? So we're not too pedantic about this, but to be technical, it's actually y hat, like this. So hat just means you're making an estimate of what the actual y is, all right? But it's not a train smash. Okay, so just keep this in mind. The y, your estimate for someone who has 65 months of experience is 484.703. But just remember, your y is in units of 1,000. Okay, so we don't expect this person to just make 484. We need to convert it back to the original units because we're saying the annual salary in thousand. So let's look at Jill, right? Her salary can't be 381 rands per year. That just doesn't make sense, right? So it's in thousands. So Jill's salary is 381,000. So for this person with 65 months of experience, we need to multiply this number by 1,000. So the actual annual salary for this person, if you multiply by 1,000, it's 484,703 rands. That's the final answer. Does that make sense, everyone? This is how you use the equation to make estimates. All right. Now, one more thing I just need to mention. Sorry, not one more thing. Just a couple of things. I want to draw your attention to something, okay? Let's clear out this board. A bit messy. Okay, so remember, this is not a perfect science, but it is definitely an educated guess. The statistical method that we're doing is way better than doing a random guess, right? So what we have to make, there's assumptions we need to make, okay? One, we assume that we can make reliable estimates based on the domain of data. And what I mean by domain, it's just a mathematical term to say that between the values of 52, which is the smallest value, so the smallest value is 52 if you look at our data, and the largest x value we have is 77. So this equation is only reliable between values of 52 and 77, right? So what we're saying is this equation, right, if I had to write it here mathematically, I would say it's only valid for x between 52. This is how you write x between 52 and 77. If you're not comfortable writing it like this, you can just write it out in words. You can say for x between 52 and 72. Yeah, just write it out in words if you don't like the math notation. Either way, it's correct. And why we say that is because between these points, between 52 and 77, we can see how these data points behave. However, after that, we don't know how it behaves because we don't have data after that. For all we know, the data could be like this, and I'll use different color here, let's say pink. The data could be going upwards like this, like that. And so if we put a straight line, if you look at this green line, it wouldn't capture the behavior after that. It would be very far off. It would be great if these pink dots were around this green line, if it was, but it isn't. It's going up. So what happens is after the domain, points beyond the domain of x, we can't make an educated guess of whether this line would make a reasonable prediction, which is why we always write this here as a disclaimer. We say that this equation is valid for x between these values. So when you write the equation out, when you write this equation out here, make sure you write this part here too. Okay, it's very important that you write this. You do get marked for that. But do you understand why you have to state that? And that's the important thing here. It's not just doing it for the sake of doing it. It's very important you understand why you state that. Okay. All right. I'm just going to see more. Good. All right. So now you've use the regression equation. Now we're going to cover something else called correlation. All right, now let me create a new board to kind of explain what correlation is. All right, correlation tells you the relationship between two things. All right, so let me just draw an axis again. Now, the example that you've just seen, right, that's an example of a positive correlation. And why I say positive correlation is because if your x increases and your y increases, so that means the line goes like this, then it's a positive correlation. And why that's positive is because it's saying as your x increases, so does your y. And that example was the more months experience you have. So if you have experience here and you have salary here, you would expect the more experience you have, the higher your salary. Okay. Now you can have things that are negatively correlated. So here it's more positive correlation. Right? Then you get negative correlation. Let's look at an example where it could be negative correlated. Let's look at something like on your x-axis, it's the amount of exercise or the hours of exercise. Exercise. All right. And then here, what you could have here, you could have stress. Could be measuring stress levels or pressure, blood pressure or something. Or even better, let's do another one. I like this one better. Your risk of heart disease. And what you expect here is the more exercise you do, the chances of you having heart disease decreases. So the relationship could be like this. And this is an example of a negative correlation. That's what correlation is. All right. Now, the second part, this graph here is telling you as your x increases, that means as your hours of exercise increase, your y decreases. All right. So that's an example of a negative correlation. All right. So that's what a correlation does. When the sign is positive, it just means it just shows the relationship between your x and y. And when it's negative, it shows you that it has an inverse relationship. As one increases, the other decreases. Now, there's a measure for correlation, and we represent that by R. Now, R can be as low as -1. So the minimum it can be is -1. This is the minimum. And the maximum it can be is +1. Now, when it's +1, it's saying it's positively correlated, as the sign says. But the 1 means it's very strongly correlated, or almost perfect correlation. What that basically means is that for those data points that I showed you earlier, the blue points, it means that the points are on the straight line. They're perfectly on the straight line like that. And then that's when you would have a correlation value of 1. However, most likely, like the data you just saw earlier, the data points aren't exactly on the line. They're slightly off like this. Okay, so like that. So then it's not exactly 1, but it's pretty close. It could be like 0.95 or 0.97, etc. Right? The higher that value is, basically the stronger that correlation is. Doesn't matter whether it's negative or positive. Even in this case, even here, these blue points, they're not perfectly on the line, but they're pretty close. You can expect a very high value, but still negative. So your R here could likely be -0.97. So the 0.97, just the value itself tells you how strong it is. Anything above 0.9 is very strong. All right. So let's work out the correlation for the example we just did. And to work that out, we're going to let our calculator do all the heavy lifting. You could use this formula here, the long method, right, which is in your formula sheet, but we're not going to do that. We are going to use the shortcut. All right. So the shortcut is to get the R, the correlation value. What you're going to do is you're going to press Shift. So press Shift. Then you're going to press 1, number 1. Then you're going to select REG, and then you will see the symbol R there. And select that, and it equals 2. And the value you should get is 0.9497, rounded, 0.9497. Let me know if you get something different, okay, if it doesn't make sense to you. So this value is positive, so that means it's a positive correlation, and it's above 0.9, so it's very strong. So that's how you would interpret it. You would say it's a very strong positive correlation. Okay, make sure you explain that. It's not enough to just calculate it, you've got to interpret it. So because the value is over 0.9, you would say it's very strong, and because it's positive, you would say it's a strong correlation. All right. Now the last term we're going to calculate now is called the coefficient of determination. All right, now it's sounds complicated, but it's actually very, very easy. All it is it's just using your R value and then squaring it. In other words, raising it to the power 2 and writing it as a percent. So your R squared is your coefficient of determination. That's the same thing. Okay, so I'll write it out. Okay, your coefficient of determination is simply just R squared, R raised to the power 2. So if you want your coefficient of determination, you just take this value here and raise it to the power 2. So it's 0.9497. We raise that to the power 2, and we write it as a percent. So if you do that, you'll get a value of 90.19%. And as before, it's not enough to just calculate it. We have to interpret this. Okay. So what your coefficient of determination tells you is how well does your X variable explain your Y variable. But you never just write it in terms of X and Y. You will write it in terms of the problem itself. For our problem, X is your months of experience and Y is your salary. So what we say is, how we interpret this, and I'll write it out, okay, just to make it neater. So you just remember this. I'm going to make space here. Okay, what we say is, we say 90.19%, okay, of the variation of salary can be explained by your experience. That's how you interpret it. Whatever that value is, then you say, whatever that percentage is, in our case it's 90.19% of the variation of salary, which is a Y, can be explained by experience, which is our X. Don't write Y and X in the interpretation, okay? Write it in terms of what the variables are itself. Okay, and we want this value to be higher, as high as possible, because when that value is low, what you're actually saying is, right now, let's put things in context. When it's low, let me just clear this part here. What you're saying is that you can change your experience, you can increase it, but if you look at your Y, it's staying relatively flat. It means it's not changing. So it means you can vary X as much as you want, but it doesn't influence your Y. And so that doesn't help us. What we want is we want an X variable that affects your Y variable, because if it does, then that means we can use it to predict salary. Because what we're saying here is you can make X whatever you want, but the salary still remains the same. So it doesn't really influence it, which is why we want this value here would likely have a very low R squared. It'll be close to 0, round about 0, 0.01. I'm making up a number, but just to give you an idea of what a low R squared means. It means your experience doesn't really, salary doesn't really vary a lot by experience. Okay, so almost no variation of your salary can be explained by experience. But in our example, what we have here, we can see that the R squared is quite high. So that means over 90% of the variation of salary can be explained by experience. All right, that's it for me this evening. That's what I wanted to cover. Does that content make sense? Does anyone have any questions? Is anything unclear?
Thank you so much for the session. Yes, it is very informative. If I may ask, which chapters is this going to be in our textbook? I haven't yet opened it.
Okay, so just to give everyone, so I'm getting questions about that. So if you go to module information, right, on ARC, go to module information on ARC, scroll down and you'll see resources says learning unit to textbook chapter mapping. If you click there, it tells you what learning unit maps to which chapter in your textbook. So for instance, learning unit 4 maps to chapter 12. And remember, the textbook that I'm referring to is the 5th edition, the latest edition, okay? So just keep that in mind.
Sure, got that. I'll just open that. I actually forget to check that PACER and all that information because of the pressure and the time. But yeah, it definitely I will. Another question, I've sent you an email, but then I'm just thinking now that we are here, let's just talk about it. The geometric mean. Do you know how do I work on it, work it on the calculator?
That's not part of this course though, right, Thomas?
It's not part of this course.
No, we don't use the geometric mean.
Oh,
So if
okay.
you're asking for this course, I wouldn't really worry about it. Don't confuse you any further. If you're asking for another course, then it's a different story.
Oh, okay. No, it is definitely for this course because you see what happened is I thought chapter 3 we're going to do everything in that, which is in learning unit. It is learning unit 3.
Oh, okay. Yeah, use the exercises in your workbook, and as a good guideline of what you can be asked. There's quite an extensive amount of questions and revision questions in it. But yeah, I'm glad you asked me. You can still ask me anyway, and I can help you. But yeah, I wouldn't focus on the geometric mean.
All right.
What
So
you
in
need to
short,
focus on is median, mode, and mean.
mean and those are the
Central measure.
yeah, and all right, no, sure. So you are basically saying I should actually check my content and the guide and in ARC for
Yeah.
if
Use the
yeah.
workbook. Yeah,
All right, thank you.
no problem. All right. That's it for me, everyone. Thanks for joining. Have a good evening.